This week on Paul Overbuilds A Workbench, we're going to make the base for our split top Roubo.
The Wood Night is sponsored by I Would Like. I'm going to start with preparing the leg stock. This goes through the usual process: cut to rough length, join one face, join one edge, thickness one side. For lamination, I cut some domino mortises and applied far too much glue. Once glued up, goes through the process again. Join one face, join one edge, run the other edge and the other face through the thicknesser before finally cutting to final length.
With the legs all square and the tabletop all square or flat, at least on the bottom side, I can now cut the mortises for the legs. Now these mortises and the tenons that go on the legs won't be glued in, but they'll be nice and snug, and there'll be lag bolts, lag screws up through the rails that'll tie the bench top down. And this is done so that the bench top can be disassembled. The whole thing will be able to be disassembled and be relatively affordable, but it will still be a very solid workbench. I'm going to cut the mortises first and then the tenons to match. And because it's 4 identical legs and 4 identical mortises, it's pretty easy to batch it out, though it will take a little bit of time. So I've marked out on both slabs. On the front slab, I marked first, got everything looking right. Then I transferred those over to the back slab, measuring from one end. That way the distance should be identical, and if I've made any mistake with the length of these slabs, though I shouldn't have, it does mean that the whole thing will still line up just fine, just might be a little bit long at one end sort of thing. So I'm going to use the router to cut out these mortises, and it's going to be a lot of material to remove. So what I'm going to do is take a pass per mortise. So I'll take a pass with the edge guide set at the furthest out. I'll do 5 mil or so and keep going down on this. Then I'll go to the next leg, start the whole process of starting off at about 5 mil, 10 mil, 15 mil, and work my way around. Then I'll adjust the edge guide and move one step in, rinse and repeat. That way it doesn't really matter what the mortises are, their size wise, they're all going to be identical because I won't adjust this between each mortise. I hope that makes sense.
I'm using a 1/2 inch spiral upcut bit here. It's recommended that you plunge no more than half the diameter of the bit per pass. The tenons are cut using a dado stack, crosscut sled and stop block.
I've moved on to the mortises in the legs for the apron pieces. That means there are 3 mortises per leg, as there are 4 short rails and 2 long rails. The short rails will get glued in, and the long rails will use these connector bolts that I made up to cinch it down to the workbench. There'll still be the mortise and tenon in those long rails, but this will provide us with the clamping pressure, and the tenon will provide some stability. So this is done in the exact same way that the mortises for the legs into the workbench top is done. That is using a router and plunging, doing multiple passes to get the width. In the case of these tenons, we only need 2 passes with a 1/2 inch bit to get what we need. You can see I've already started and forgot to actually start recording. I've clamped 2 legs together. Now all the legs are the same dimension, so it makes it quite easy. And by clamping it together, it allows us to have a much more stable platform for it to rest on. So you can see here I've done the 2 passes needed for the short rails, and the long rails are on the edge of the legs, so they're slightly different positioning from the fence because I'm using it from the far side rather than from the close side, and that just, as I said, gives me more meat to rest the whole router on. So I've got my start and stop line, so what I'll do is plunge down full depth at the start and stop lines, then work away at the material in between. That way I don't have to keep continuously sort of check on that line. I just have to go until the router has less pressure on it because it's not cutting away any more material.
Here I varied it up a bit and found that for short mortises like this, a peck drilling style motion was actually very efficient. Just like before, the tenons are cut using a dado stack, cross-cut sled and stop block.
Currently nothing is glued up, but this is a good dry fit to see that everything does indeed fit. So we're just about ready to do the glue up of the 2 end assemblies. But before we can do that, I need to cut a rebate in the bottom short rails and the long rails to accept a shelf. Now the shelf is going to be a ship-lapped panel shelf, but it still needs a rabbet rebate or a sort of a ledge for it to sit on. I'm going to go with the rebate option because that's nice and easy. So I need to disassemble all of this, take it over to the router table, and then the 4 bottom pieces will receive 20 by 15 mil rebate.
I know I said router table, but I remembered I had the dado stack already set up, and this was much quicker. The excess material was just snapped off.
Before I glue up the 2 end assemblies, I really need to drill the holes for the vise components. I can do that later, but it's a lot more work to do it later, so I'll do it now. Need to drill 3 holes. First hole is for the bearing for the parallel guide. It'll be a 54 mil hole that goes down about 8 millimeters, and that's for this flange here. Then we need to drill a through hole that's 32 millimeters for the rest of the bearing housing. After that's done, I can move the workpiece so that the hole for the screw, the wooden screw, can be drilled. So that'll be a 38 millimeter hole. That'll be just slightly larger than this screw, and then there'll be a vise nut on the back that actually provides the clamping action.
Assembly was a fairly straightforward process. For these larger projects, I'm trialling Titebond Extend, which gives me a bit more open time. It helps make these sort of projects less stressful. It's cheaper than liquid hide glue, but it's not as easy to work with, so I'm not sure I'd say it's a win just yet. I use the workbench top to help clamp everything in the right spot.
So the workbench, when flipped up onto its legs, is pretty stable as it is, but without the long stretches being glued in. It's never going to be 100% stable. So the solution I'm using is, as I've mentioned, the Knockdown Hardware. So these aluminium bench bolts, bench nuts and bench bolts that I made. And this will allow me to knock down the workbench for transportation and other reasons. So what I need to do now is drill through this mortise so that the bench bolt can sit through like that. Then we can transfer that to the individual tenons, go through the stretches that way. To transfer this over to the other side, because we need to drill on the other side to allow for the head of the bolt and for the washer, I'm going to use a saddle square. A regular square will work just fine, but a saddle square does make it a lot easier to transfer lines over an edge, simply because you hold it up and that's it. You don't really need to measure anything. However, this one is pretty short, so I will extend that line with a regular square. So these are the two lines for the mortise that have been transferred around, but that doesn't give me the center point. So I've measured to the center point of the mortise on the other side. I can transfer that line between these 2 points. Now I need to find the center point between these two lines, and that's where we can actually drill. Though I'm not a massive fan of it, these centering rulers do make it quite easy to get the center point without having to do too much thinking. So we're looking at about 33 makes the center point. I've got the long stretches in, the clamp is there to help hold everything so nothing wobbles. And I need to extend these holes for the bolts into the tenons. Now obviously my drill bit's not going to go all the way through to where we need it to go, it's not as long as the bolt itself. But I can extend it through the tenons, and then that should give me enough of a pilot hole to continue drilling this all the way through. That's about as far as I can get with this one, so now I need to go around to the other three. Before I disassemble the bench, I want to mark out where the bolt will end up at so we can place the nuts. The bolt is roughly going to be like that, so we can measure the length of that with a square. So it's going to fall somewhere on that line. We don't quite want to put our nut there because it'll only engage the last few threads. If we measure in 1/2 inch from that line, because that is a 1 inch aluminium nut, will give us probably the best result. Doesn't have to be super accurate on that location because there is a little bit of wriggle room for it. The next thing to do is get the center point where that hole is to line up so that we have a straight bolt running through.
Even though it was a brand new drill bit, it was very slightly undersized, which meant a lot of percussive persuasion was needed to get the nut in.
That pretty much wraps it up for this video. You might wonder why I don't have the top of the workbench on, and that's because it's heavy. I really don't want to have to take it on and off a whole bunch of times because it's heavy. I've done that enough. So now that everything fits, I've got a few things left to do on the workbench that we'll get to next time. Then once it's on, hopefully that'll be the last time I need to move it for quite some time because it's heavy. Thanks for watching.